So in the today's topic, we will discuss about the algebraic structure. So we already know about the some sets like set Z, that is a set of integers. Then set Zn, that is set of integers with the residue and multiplicative inverse set. Like this type of set we already know. So when these sets are associated with some operations, okay, these sets are associated some operations that are applied to the element on the set. So ऑपरेशन कहाँ पे अप्लाइड होंगे? जो भी एलिमेंट, जो भी सेट के अंदर जो भी एलिमेंट होंगे उनके ऊपर अप्लाइड होंगे. So set Z, Zn and Zn star are associated with some operations that are applied to the elements on the set. Is called algebraic structures. In the short form मैं ES लिख रही हूँ, ठीक है? It's called algebraic structure. So there are three common types of the algebraic structure. The first one is groups, second one is ring, and the last one is fields. So these two, that is groups and fields, are important for the cryptographic point of view. So one by one we will see what is that. So the first one is groups. So what is groups basically? A group is denoted by capital G. So let me write the definition first. A group G is called, a group G is a set of elements with binary operation So the binary operation is denoted by this dot. This binary operation can be multiplication, addition, and subtraction that satisfy the four property. That satisfy four properties. What are that properties? Or sometimes it is called axioms. So the first property is called closure. So what is the closure basically? So closure property says that if A and B are elements of G, if A and B are elements of group G, then the operation C equal to A dot B, dot is the binary operation, so C equal to dot AB is also an element of G. Okay, now the second property. Second property says we have to involve three elements. So the three elements are A, B and C. So if A, B and C are the elements of the group, then it should follow the property of associativity. Okay. Now the third one is existence of identity. So what is existence of identity? For all the elements in G, there exists an element E, identity element, such that if you perform the binary operation between the identity element and all the elements, you will get the same element. It can be understood like if suppose your element is A and if you multiply it by with 1, then it will give you the same result, the mirroring concept. For the addition, if you add with 0, then you will get the same result. So for the addition operation, the identity element will be 0. For the multiplication operation, the identity element will be 1. So for the group, the definition will be for all A in G, all elements in G, there exists an element E, means identity element, such that A and perform binary operation with the identity element, or you can say E and binary operation with element, you will get the same result. So mirroring concept. The fourth one is existence of inverse. So for each A in G, there exists an element A dash, means inverse of A, such that A and binary operation with A dash or A dash binary operation with A, then you will get the identity element. Okay. So there are 4 properties. If the 4 properties are satisfied, then we can say the given set is a group. Now another thing is commutative group. So what is commutative group? Commutative group is called, let me write the definition. A group is called commutative group if it follows 4 properties above, 4 properties with one more property additionally. So what is that additional property? The additional property is named as commutativity. So what the commutativity says? So in the combined way, you have to write the first property is closure, second property is associativity, to be group, and when it is a commutative group, you have to follow these all properties one by one, like closure, associativity. The third one is additional one, that is commutativity. Fourth one is existence of inverse and existence of identity. So existence of identity I will write first. And the last one is existence of identity. If these 5 properties are satisfied, then we can say our group is a commutative group. Otherwise, if 4 properties are satisfied and the commutativity is not satisfied, then we can say it is a group only. So what is the commutativity says? It says if A and B are the elements of A, then the binary operation between these two elements should be equal to A dot B equal to B dot A. So that is the rule of commutativity. So for example, for the understanding point of view, I am taking one example. Suppose set of residue with addition operation. We have a group and having a set of residue, and my binary operation is addition. Now we have to check is a commutative group or not. So for being commutative group, we have to satisfy all the 5 properties. One by one I have to check. The first one is closure. So for the closure, C equal to A plus B. So obviously C will also be the part of Zn. So we can say closure property will be satisfied. If there is C out of range, then I will perform the modulo operation, that is modern, because it is set of residue. So we can say that yes, closure property satisfies. Second is associativity. So for that, it will satisfy by this one. Obviously for the addition, normal addition, associativity rule applies. So this rule is also hold. Now second one is commutativity, because we are talking about the commutative group na. So it holds this property. We can check, like if we perform the addition between two elements, then the reversing addition will also follow the same and it will produce the same result, like 2 plus 3 equal to 5 and 3 plus 2 equal to 5. Now the fourth one is existence of identity. So for the existence of identity, as you know, this is a plus operation, means addition operation. So for the addition operation, the identity element should be 0. And existence of inverse. So because we are talking about the addition one, so when we are performing the addition set of residue, so we already know, inverse. So we already know that each element of the set of residue will contain its inverse. So yes, A plus B and mod n equal to 1. So it will exist. Now what about the another example? Another example will be group having the set of residue. Because we cannot take the set of residue directly, so we have to take only those elements having the multiplicative inverse possible in order to satisfy the fifth one property. And my operation is multiplication 1. So we have to find out this group is commutative group or not. So for this, we have to check all of the 5 properties one by one. So the first property is closure. So yes, A cross B equal to C will also belong to this set. If it is out of range, then we have to perform the modulo operation. Second one is associativity. Yes, this property will also hold if if we perform the multiplication by this way, we can get the same result. Now the commutativity. So for the commutativity, A cross B will also equal to reverse process, that is B cross A. Fourth one, existence of inverse. So for the inverse, because we are talking about the set of residues which each having contained the multiplicative inverse, so yes, we can find out the inverse. Now the fifth one, that is existence of identity. So as you know, for the multiplication, the identity element is 1. So yes, this group is a commutative group. Again, we have one example in order to understand it more properly. So in this in this example, we have one table. So in the table, we have some values like the number of elements are A, B, C, D, and the operation is dot operation. So B, C, and D, and this table values are given to you. So what are that table values in this question? So A, B, C, D is given to you. Second row is B, C, D, A, C, D, A, B, and D, A, B, C. Now the question is, you have to find out it is commutative group or not. So for the commutative group, first one by one we have to check for the properties. The first property is closure 1. So closure says that binary operation is dot. So A dot B equal to what? Equal to C. So यहाँ पे find करो A and dot operation with C. Dot operation of B equal to C. आ रहा है क्या? नहीं आ रहा है. So A dot C equal to C. So कहने का मतलब है कि अगर हम कोई भी एलिमेंट ले और उनके ऊपर डॉट ऑपरेशन परफॉर्म करें, so whatever the outcome is producing by the table, it will go to the result, means it will be belong to the result. So हम यहाँ पे देखेंगे A dot B क्या आउटकम प्रोड्यूस कर रहा है? A dot B मेरा B प्रोड्यूस कर रहा है. So yes, B is inside the set. So A dot A equal to A is also belong to the set. A dot C equal to C. C is also belong to the set, and A dot D equal to D is also belong to the set. So we can say yes. Now the second one is associativity. So for the associativity, A dot B dot C should be equal to A dot B dot C. Let us check from the table what is the outcome of B dot C. So B and dot C, that is D, and A and dot D equal to D. For the RHS, A dot B equal to B and B dot C equal to D. So yes, associativity rule holds. Third one is commutativity. Commutativity rule says A dot B should be equal to B dot A. So let us find A dot B equal to B, yes, and B dot A equal to B, yes. So it holds. Now the another one. The fourth one is existence of identity. So for the existence of identity, there should be element in the set such that if you perform the binary operation with the element, you will get the same result, means the mirroring concept. So is there any element exist? Yes, it is the element exist over there. So existence of identity of each element is exist. And existence of inverse, So we have to perform the binary operation with some value in such a way that you will get the 1 value. So such type of elements exist to us in this table or not? Yes, it is exist. So it will be multiplied with the A inverse. भाई A तो अवेलेबल है ना, A को बस हम क्या कर देंगे 1 डिवाइडेड बाई A कर देंगे, तो वो एलिमेंट प्रोड्यूस है और वो मेरा 1 मुझे देगा. So we can say the existence of inverse. What is the inverse element in this case? Inverse element is A. So A is belong to the set? Yes, A is belong to the set. So we can say this table holds a commutative group property. Now some more important terms. So important terms are the first one, that is finite group. Second one is order of a group. And the third one is subgroup. So what is finite group? Finite group is very simple. A group is called finite group if set has a finite number of elements. If set has finite number of elements. Otherwise it is called infinite group. What is the order of elements? Order of elements means number of elements present in the set. Number of elements. And it is presented by this one, group G. So suppose if your set having infinite number of elements, so in that case order is also infinite, right? And then what is the subgroups? Subgroups is a subset H. A subset H of a group G is called a subgroup of G if H itself a group, means H should satisfy all of the 4 properties with respect to the same operation associated with the group G. With respect to same operation as G. So operation should be same. Okay. So subset H of a group G is a subgroup of G if H itself a group, means it holds 4 properties, and for the commutative group it has to hold 5 properties with respect to the same operation that are ongoing over the group G. So suppose if a group G having some elements with binary operation and is a group. Now there is some another group that is H having T number of elements, means set of residuals is denoted by T, and operation is same, that is binary operation is group under the same operation. It is also a group. And T is a non-empty subset of S. T क्या है? It is a non-empty subset of S. So in this condition, H is called the subgroup of G if the first property A and B are the members of both the groups elements A and B should be member of both groups, and C equal to A dot B should be member of both the groups. Also, both group G and H share the same identity element. Means identity element must be same. Then if A is a member of both the groups, then inverse of A is also the member of both groups. If A is a member of both groups, then it inverse means A inverse should be the member of both groups. तो ऐसा नहीं होना चाहिए कि मेरा A वाला एलिमेंट इधर है और A का इनवर्स इधर है, ठीक है। तो अगर A यहाँ पे है तो उसका A इनवर्स भी सेम ग्रुप में होना चाहिए, ठीक है। मीन्स अगर यहाँ पे B है तो उसका B इनवर्स भी यहाँ पे होना चाहिए। साथ ही दोनों शेयर करने चाहिए सेम आइडेंटिटी एलिमेंट एंड वो सारी प्रॉपर्टीज को होल्ड भी करना चाहिए टू बी फॉर्म अ ग्रुप और अ कम्यूटेटिव ग्रुप, ठीक है। सो ये तीन प्रॉपर्टीज को होल्ड करनी चाहिए, देन वी कैन से H is a subgroup of G. Now the question is, suppose a group is given H is Z10 and plus operation, and another group G is given with Z12 and plus operation. Now the question is, we have to find out that H is a subgroup of G or not. H is subgroup of G or not. Okay. So in this case, first we have to find out the operation is same or not. The operation associated with the H and the operation associated with plus is same. Okay. Now there are two types of operation involved in this group. The first one is addition and the second one is mod 10. Here, what is the operation? Addition, and the second operation is mod 12. So here it is a difference. We are performing mod 10 here and we are performing mod 12 over here. So we can say that H is not a subgroup of G because operation must be same. So the answer is no. Now the other topic is called cyclic subgroups. So what is subgroup? We already know about that. Now the time for understanding the cyclic subgroup. So in the cyclic subgroup, if a subgroup of a G if a subgroup of a given group can be generated using power of an element and the element should belong to the group. So if a subgroup of a group can be generated using the power of an element, then the generated subgroup is called cyclic subgroup. So let me explain one question such that you can better understand how to generate the cyclic subgroups from a group by using the power of an element. So the question is, how many subgroups can be formed by using group G equal to, we have set of residuals Z6 and the operation is addition. Now from the set of residuals, what are my values? Values are 0, 1, 2, 3, 4 and 5. Okay. So we have to pick all of the element values one by one and situate its power like 0 to the power 0, 0 to the power 1, 0 to the power 3 up to 5. And we have to find out what are the values generated from this task. So whenever there is a repetition, we have to stop. So let me tell you how this works. So the first is cyclic subgroup generated from 0, because first element is 0 now. So 0 and here is H and the subscript will be number of elements generated from this element. So the power is 0 to the power 0 mod 6 because set of residuals is 6 over there. 0 to the power 1 mod 6, 0 to the power 2 mod 6, 0 to the power 3 mod 6, 0 to the power 4 mod 6, 0 to the power 5 mod 6, and we have to stop over there because maximum power is stopping over there means 5. So 0 to the power mod 6 equal to 0. It will be 0, it will be 0, also it will be 0, 0 and 0. Because there is a repetition over there. Na? So we have to stop over there and there will be only one element, that is 0. So it will be indicated as H1. What is the element generated by it? That is 0 in the curly braces and the operation is plus. Okay. So that is cyclic subgroup generated from 0. तो साइकिल कहाँ पे आ रही है? यहीं पे आ जा रही है. पहला एलिमेंट जनरेट करने के बाद ही दोबारा मेरा 0 आ रहा है. There is a repetition over there. So it is a cyclic subgroup. So subgroup in this case because we are not able to generate all of the elements in the set like 0, 1, 2, 3, 4, 5. I am generating only the value 0. So it's a subset. So 0 over there. Now the second one. Second one is cyclic subgroup generated from second element. What is second element? That is 1. So 1 to the power 0 mod 6, 1 to the power 1 mod 6, 1 to the power 2 mod 6. So I will compute the output also. So 1 to the power 0. So 0. 1 to the power 1, 1. And 1 to the power 2 mod 6 means it is not equal to 1. It will be 1 plus 1 and mod 6 because we are performing the addition one. Na? Kya tha mera group? That is Z6 and plus. So addition operation you have to perform. So it will be 2. So 1 to the power 3 mod 6 equal to 3. 1 to the power 4 mod 6 4 5. 1 to the power 5 mod 6 that is 2. 1 to the power 3 mod 6 that is 3. 1 to the power 4 mod 6 that is 4. 1 to the power 5 mod 6 that is 5. Okay. So all the powers are finished, like from 0, 1, 2, 3, 4, 5, whatever the elements the Z6 containing, and it has ability to generate all of the elements that are in the group. So what are the elements? 0, 1, 2, 3, 4, 5. So we can say it is a cyclic subgroup as well as it is a cyclic group. Why it is group? Because this H and the number of element is 6. And what are the elements over there? That is 0, 1, 2, 3, 4 and 5, and the operation is plus 1. So the number of elements is similar to the number of this element, that is Z6. So we can say Z6 is a cyclic subgroup as well as it is a cyclic group. And in that case, when an element has ability to generate all of the elements in the set, the ability of the element 1 is to generate all of the elements of the group, that is 0, 1, 2, 3, 4, 5, with having all of the powers, with the computation of having all of the powers, then this type of element is called generator. Generator of group. And this type of group is called cyclic group as well as cyclic subgroup. Now, testing for the third one. So for the third one, cyclic subgroup generated from 2. 2 to the power 0 and mod 6. What is the value? 0. 2 to the power 1 mod 6. Answer is 2. 2 to the power 2 mod 6. Answer is 4. 2 to the power 3 mod 6. And answer is 0. Because we have to perform the performing the addition operation. So 2 plus 2 plus 2 and mod 6. So the answer is 0 over there because 6 mod 6 equal to 0. Because there is a repetition, 0 is occurring second time. So we have to stop the process over there. And what are the cyclic subgroup? That is H3, H, and this is the number of elements. How many elements it have generated? 0 to 4 means 3 elements are generated. What are that elements? 0 to 4 and the operation is plus 1. So it is a cyclic subgroup and it generates 0 to 4 elements. Then the fourth one, generated from cyclic subgroup, generated from 3. So 3 to the power 0 mod 6 means 0. 3 to the power 1 mod 6 means 3. 3 to the power 2 mod 6 means 3 plus 3 equal to, mod 6 will be equal to 6 mod 6 and it should be 0. So there is a second time occurrences of 0 So we have to stop over. And how many number of elements it will generate? That's 2 elements. So H and the number of elements. What are that elements? That is 0 and 3. And the operation is addition. Now the fifth one, that is generated from 4. So 4 to the power 0 mod 6. 0. 4 to the power 1 mod 6. 4. 4 to the power 2 mod 6. 4 plus 4 equal to 8. 8 mod 6 equal to 2. So 4 to the power 3 mod 6. So 4 plus 4 plus 4 yani ki 12. 12 mod 6 equal to 0. So here is a repetition. So repetition means I have to stop how many number of elements? H3. What are that elements? 0, 4, 2. And the operation is plus 1. Now the last one. Last one is cyclic subgroup generated from fifth element, like the 5. So generated from 5. So 5 to the power 0 mod 6 equal to 0. 5 to the power 1 mod 6 equal to 5. 5 to the power 2 mod 6 equal to 4. 5 to the power 3 mod 6 equal to 3. 5 to the power 4 mod 6 equal to 2. 5 to the power 5 mod 6 equal to 1. Now all the powers are finished. Like what are the number of elements? What are the elements? Z6 contains 0, 1, 2, 3, 4, 5. All other elements are finished in the terms of the power, and there is a no repetition. So we can say it is a group, and 5 is a generator. So how many numbers it will generate? As 6. What are the elements? 0, 1, 2, 3, 4, 5. With respect to addition operation, so it is called cyclic group.